everyone. Next, we will understand groundwater, and study the engineering geological issues concerning groundwater. Groundwater is a general term of various forms of water that exist in the voids of rock and soil beneath the Earth's surface. It mainly originates from the infiltration water of surface water bodies, rainfall, river water, and so on. Condensate water formed when water vapor condenses in the pores of soil or rock upon cooling. Magma spill water separated from magma, and the pent-up water enclosed in rock formations of ancient lakes. Depending on different groundwater storage methods, groundwater can be divided into vadose zone water, phreatic water, and confined water. We will now explore them in turn. As shown in the figure, vadose zone water refers to the water existing in the vadose zone below the ground. With a not large volume, the vadose zone water has strong seasonal variations and a low degree of mineralization, but water is susceptible to pollution. Its replenishing and distribution areas are consistent. Phreatic water refers to the gravitational water buried in the saturated zone with free water surface. Above the first stable water-resisting layer beneath the Earth's surface, phreatic water is connected to the atmosphere with free water surface, and it is unpressurized water, so it is directly replenished by atmosphere. Its replenishing and distribution areas are consistent, but it is greatly affected by climate, with obvious seasonal variation characteristics. It is buried deeply and can be used as a water source, but it is susceptible to ground contamination. The confined water is different from the phreatic layer. Confined water refers to the groundwater that is buried and fills the aquifer between two water-resisting layers. It is the pressurized gravitational water without free water surface. It withstands a certain hydrostatic pressure, which is easy to cause water bursting. It is buried deeply, with often relatively stable volume. Confined water is less affected by climate and regarded as a good water source. It is unsusceptible to ground contamination, but its replenishing and distribution areas are inconsistent in most cases. So, what are groundwater replenishing and discharge? Groundwater recharge refers to the process of groundwater replenishing through various ways, such as rainfall, irrigation, underground runoffs, and seepage of channels or rivers. Groundwater is mainly discharged by evaporation, transpiration, discharge, springs, and artificial discharge. Springs are natural outcrops of groundwater and mainly formed when groundwater or aquifer channels are exposed above the Earth's surface. Springs are one of the main discharge methods of groundwater. Based on replenishing sources and water flow characteristics, springs can be divided into ascending spring and descending spring. Based on the reasons for spring water outlet, springs can be divided into erosion spring, contact spring, and overflow spring. Based on spring temperature, springs can be divided into cold spring and hot spring. Next, we will learn the law of groundwater movement. The movement of groundwater in the voids of rocks is called seepage or infiltration. The area with seepage is called seepage field. The actual movement speed, direction, and law of groundwater particles are rather complex, which is hard to be solved based on the actual movement. Therefore, in actual analysis, water is usually simplified to the continuous imaginary water flow instead. According to water particle movement, there are laminar flow and turbulent flow. Groundwater seepage mostly shows laminar motion. Based on such seepage elements as flow rate, seepage is divided into unsteady and unsteady flows. Water movement in which all seepage elements will not change over time is called a steady flow, Otherwise, it is called the unsteady flow motion of groundwater. Most groundwater movements are considered as unsteady laminar flows. In the end, we will learn about the impact of groundwater on projects. Groundwater often has a certain impact on projects. For example, land subsidence has become the mostly occurring geological disaster in Shanghai. The main reason is that the decline of groundwater level leads to a decrease in pore water pressure. To achieve balance, effective stress increases, causing soil compression and settlement. In addition to this, in saturated soil, if the effective stress between soil particles is zero, soil particles will be suspended in water and flow out with water, which is called quicksand. Under the action of osmotic force, fine particles in the soil pass through the voids between coarse particles, and they are gradually carried away through seepage. As time passes, soil structure is destroyed, with intensity decreased and compressibility improved, which is called subsurface erosion. Therefore, geological impact occurs on projects. Through the learning in this lesson, we have learned about the groundwater, and the engineering geological issues concerning groundwater. We also complete this chapter. Please complete the exercises carefully.